Yeah, hello all of you. Welcome to Spark Academy. This is Anupama Physics from Spark Academy, and today we are going to discuss a few things about the reflection of light on plane surfaces. Okay, so this session is all about the reflection on plane surfaces and also reflection on plane surface, and also we will learn like how light behaves after reflection, like how velocity changes and all, right? So we'll just go to that. We'll just wait for a couple of minutes and then start the live session on reflection on plane surfaces. Okay, so before we go there, let us actually discuss what all are the things we usually observe, on reflection in day-to-day life. Like we all know, light is very, very important to us, isn't it? Right? Without light, we cannot see the objects around us, right? So what is all happening here? Like initially, what happens is light. We know that sun is the main source of light, isn't it? Right? So that light falls on the all the objects on the surface of the earth or around us, and then they reflects back, and once they reflects back, when those reflected light rays falls on our eye, then we are able to see the images of all the objects around us. Okay, so this is about the this is how reflection is very, very important in day to day life, isn't it? This all of us know actually, isn't it? So now let us see how important reflection of light examination point of view. Okay, this comes in the second year syllabus, and this is this is very, very important examination point of view. Okay, so now coming to the reflection of light. Okay. Mm, yeah, as I told you, today's class is all about light. Okay, all about light and reflection of light, right? So my name is Anupama, and you all know I am from Spark Academy. And Spark download our app. We have an app which offers you different courses like NEET, EAMCET, IIT, Advanced, mains, and all that, and short term and long term courses also we have. And then the advantage, once you download the app, once you register yourself onto the app, like we have live sessions here. So this live sessions can be recorded, means include live sessions are there and also recording sessions are there. Even if you miss one of the classes, then you can see the classes anytime. Okay, so that is the advantage of the Spark Academy app. Okay, and then next one here, we have weekly schedules, weekly examination schedules, and we have assignment sessions. We have assignment sessions, and yeah we have assignment sessions too. And see, you can see here on the screen it is visible. And also once the test is done, the analysis will be given, like grades are given like this. Okay, and then as I told you, the app also consists of the old question papers, the previous year question papers, which are actually solved, so that the child can learn directly from there. By seeing the question papers, you will come to know what's the weightage of each chapter, and then they are very much helpful. We have a telegram, we have even the telegram too. Just download telegram, and through this link you can add yourself to our telegram channel too. Okay, so this is about the Spark Academy and the courses you can see here. Like we have EAMCET, and even study materials also you can buy. And then crash course we have, and EAMCET long term, short term, mains, and NEET. Okay. So as you all know, we have online and offline coaching facilities also. Okay, online and offline facilities are there. So you can utilize anything depending upon your requirement. So that is about the Spark Academy. Now let us come to our topic. Okay, as I told you, today's topic is about light, reflection of light. Reflection of light. I think you all know that what is reflection, isn't it? When any light ray falls on any surface and then bounces back to the same medium, then that is called as a reflection. Like for example, if you take any reflecting surface, light ray falls on the surface and then bounces back, then this is called as a reflection. Okay, and all the bodies are not reflecting bodies. There are few bodies which are reflecting. Like I can say, we all are reflecting surfaces. When light falls on us, it just reflects, bounces back. Okay, that is the reason why we are able to see our own images in the mirror. So this is what is called as reflection. Light falling on any surface and then bouncing back is called as reflection. Bouncing back to the same medium. Medium is nothing but a part of matter in which energy can be transferred from one place to another place. So this is about reflection of light. And as I told you the beginning of this chapter, we are going to discuss about the reflection of light on plane surfaces. Okay, right? Later we will discuss about the curved surfaces, but this class is all about the reflection of light on plane surfaces, right? So before we go there, we have to learn about the laws of reflection. I hope you all know what are all the laws of reflection, isn't it? The first law of reflection is angle I is always equals to angle R. What is this angle I and angle R? Let us see. Like let us draw a line, and then this is nothing but the incident ray and this is the reflected ray. And what do you call this as? This is the normal. Normal is an imaginary line which is drawn perpendicular to the surface. An angle made by the incident ray to the normal is called as angle of incidence, which is represented by angle I. And angle made by reflected ray to the normal is called as angle of reflection. Okay, angle of reflection. And according to the reflection of light, laws of reflection, angle I is equals to angle R. Okay, always. Okay, angle I is equals to angle R. And then second is the incident ray, reflected ray, and the normal lies on the same plane. So lies on the same plane, right? So this is what is the very important introduction of this reflection of light. And whatever we are going to learn about the reflection, we are going to learn only, basing on this only. Okay, right? As I told you, the topic weightage is a lot of weightage is there for this topic. Usually the ray diagrams, even the curved surfaces, if you learn, then once we learn the curved surfaces, too many problems will be coming from the curved surfaces. And At least maximum of one or two definitely will come in EAMCET. Okay, so this is about the topic weightage. So now, as I told you, here in this lesson we are going to learn about reflection on plane mirrors and see how they are applicable while doing the problems. Okay, so reflection on plane mirrors, like, yeah, what are the, what happens, how the reflection takes place in the plane mirrors. Like, for example, I am standing in front of the mirror and I want to see my own image on the mirror. What happens here? Like, first, as I told you, light falls on me and then they reflects back and falls on the mirror so that we can see our own image on the mirror. Isn't it right? So what is happening here? Like, for example, an object is placed somewhere here and the distance from the object to the mirror, usually we represent mirror like this, plane mirror or any type of curved mirror too, and the distance from the object to the mirror is nothing but u, and distance from the mirror to the image is nothing but is represented by v. Okay, so what is happening here? Light rays from the object falls on the mirror initially and then the image will be formed somewhere at the back of the mirror. Okay, and then once the image is formed at the back of the mirror, those light rays just comes back and falls on our eye so that we can see the image of our own, our own image in the mirror. This is what is happening. What are the characteristics of the image formed in the mirror here? The very important characteristic of image formed is u is equals to v. Means object distance is equals to image distance. For example, you are standing 3 meters from the mirror. Then your image will be formed 3 meters from the mirror, back side of the mirror. And if you are moving 2 meters away from the mirror, then even your image also moves 2 meters away. Meaning 3 plus 2, how much? 5. If object distance is 5, then image distance also becomes 5 here. So u is equals to v. This is the first characteristic. And the second characteristic is that the image which is formed is virtual and erect. Virtual images are those images which cannot be caught on the screen. We cannot catch on the screen. They are formed somewhere, but we cannot catch on the screen. So those are the virtual images, and the image which is formed in the mirror is virtual and erect image, right? Erect means straight image. It is not inverted. Inverted means upside down. Here it is straight image, erect image, right? So this is about virtual and erect, and most importantly, the image which is formed is undergoes lateral inversion. Lateral inversion means what? Left looks like right and right looks like left. Okay. Like, for example, you are seeing an image like yes in the mirror. Then the image looks like this. Means left look like right and right looks like left. Okay. So this is about lateral inversion. Okay. Like you can see even the images of the books also in the mirror. Like they'll undergo lateral inversion. That is a perfect example there. So this is how, these are some characteristics, these are the characteristics of image formed in the plane mirror. Like, for example, a person of height h wants to see his own image in the mirror, the full image of the mirror. Okay, wants to see full image in the mirror. Then what should be the image height here? The height of the, what should be the height of the mirror? The height of the mirror is, minimum height of the mirror should be h by 2. Okay, half of its height. Like, for example, a 6 feet man wants to see his image, full image in the mirror. Then he requires minimum of 3 feet mirror so that he can see his full length image in the mirror, right? So this is one thing which we have to keep in discussion. And second thing is that, for example, we are standing in front of the mirror and then there is a wall backside of me. So, for example, I am standing in front of the mirror and there is a wall backside to me. If I want to see the full image of the wall height h in the mirror, then the mirror height should be h by 3. Okay, like wall height is h, then mirror height should be h by 3, means 1/3 of the height of the wall, so that I can see the full image of the wall in the mirror. Okay, so this is how we use the plane mirrors. And then next thing is plane mirrors are also used for, as I told you, lateral inversion, isn't it, right? They are used for lateral inversion. Now, for example, I am using plane mirror for rotation of the mirrors. Like I am rotating the mirrors. Okay, like there is a mirror. Okay, and then this is the normal, and there is an incident ray, and this is the reflected ray. Okay, this is I, this is R. So what happens if you rotate the mirror by theta, by an angle theta? I am just rotating it. Means mirror was like this, and now I am moving the mirror slightly by theta. Then what happens here? What happens to the incident ray? Incident ray doesn't change. No change in the incident ray because I am not changing the source, isn't it? Until and unless I change the source, I changes. But here, R definitely changes. R becomes, means angle of reflection becomes 2 times of the theta. Okay, if I am moving 15 degrees mirror, I am rotating mirror by 15 degrees, then the theta also, R changes to 30 degrees more, 2 times of that. So this is how the rotation of the mirror is, right? So this is one thing. And the second thing is, like in the previous thing, we have seen a light ray which is actually reflected back. But instead of reflecting, actually light ray should go straight, isn't it, right? Instead of going straight, it is reflecting back. Then what is this angle actually called as? This angle is called as angle of deviation. This angle is called as angle of deviation. Angle of deviation is nothing but the light ray, how much it is deviated, which is represented by D, is equals to 180 minus 2 theta. Like theta is nothing but I or R. Here theta is equals to either I or R. I anyway equals to R, either I or R. Okay, so this is about angle of angle of deviation. Okay, so this, and next we have inclination of the mirrors. Inclination of the mirrors, meaning when you are inclining the mirrors like this, 2 mirrors with some angle in between them. Theta is the angle in between them. What happens to the number of images? Like if I use one mirror, I will get only one image, no doubt about it. But here, if you are inclining the mirrors and you are placing an object somewhere here, then what happens to the number of images here? Like, the number of images changes, like multiple reflections takes place, and n number of images also. It's not one. It definitely will be more than one, right? So that number of image depends upon theta value here. So n is equals to 360 by theta minus 1. Okay. If it is even, then you have to take minus 1. You have to see that always the number of images should be equal to odd in number. Okay. Because why odd in number means, like 1, 2, 3, 4. Somewhere at one mirror it has to stop. So the final image will be the odd image. That is the reason why whenever you are calculating the number of images by using this particular formula, you have to see that. That is the reason why we are subtracting -1. If you are getting an odd by using 360 by theta, then you can leave it. No need to do -1. If you are not getting, then you have to subtract. Okay, this is only for the even number of images. For odd number of images, it is only 360 by theta. Okay, so this is how we find out the number of image. For example, there are two mirrors which are parallel to each other. Then what will be the number of images here? N is equals to what? 360 by parallel means theta is 0. That is, it will be infinite number of images will be there. So multiple reflection takes place. That is, this particular parallel mirrors we usually see in the switch shops, where number of images you can see there. Okay, so n is equals to 360 by 0. Theta is nothing but 0, which leads to the infinite number of images. Now for example, there are two mirrors which are perpendicular to each other. Then what will be the number of images? First we will see 360 by 90 and then see 9 4s, isn't it right? 4 is an even number, but what I said, it should be equal to odd. So this will be 4 minus 1, that is 3 images. So in this way we can find out the number of images by using the simple formula n is equals to 360 by theta minus 1. Then what happens to the light ray here? Even the light ray also, it just deviates. They are not going straight. Many deviations are taking place. And even in this case also we get angle of deviation. Angle of deviation in such inclination of mirror is given by D is equals to, angle D is equals to 360 minus 2 theta. Okay. So this is how we find out the number of images. Right? Okay. So now we will see how to find out the mirror images. Mirror images of clocks. Mirror images of clocks. Like for example, a clock is there in front of the mirror, and then the clock is showing the actual time of the clock is 8:35, for example, 8:35 p.m. Okay, then what will be the time in the mirror? Okay, it will not be same, because the image undergoes lateral inversion. Left looks like right and right looks like left. So the image, the time will be something different in the mirror. Okay, like for example, if you take a watch here and you see, usually if it is like this, it's not exactly this time. If it is like this, then this is original and the mirror image will be like this. Mirror image will be, this will come this side. Means short hand comes this side and long hand shows this side. This is how it will be. So exact time, how can you find out? There is a small tip here. Okay. To find out, for example, 8:35 is the original time. Then in the mirror, what is the exact time it is showing? Let us see. For that, you need to take 11:59. Okay, because total 12 hours, but you will see 11:59, subtract and add on, subtract 1. I'll tell you. 11:59, and then the time what it is showing is 8:35. Now subtract. 9 minus 5 is 4, 5 minus 3 is 2, and 11 minus 8 is 3. Right? Means in watch, in mirror, what time it is showing? 8:24. Not 8:24. You can round figure to 8:25 or 3:25 also. Okay. So this is how we find out the mirror images. Okay. Now, once we will do one more thing. Like there's a mirror somewhere here. like the two mirrors are inclined in this way. Okay, and light, this is the normal, and the light is falling somewhere here. This is theta. Now what he is asking is, there are two plane mirrors which are right angles to each other. Okay. Now with what angle the light ray comes out, he is asking. Like with a what angle? For example, after reflection, this goes and falls in the mirror, in the other mirror. Anyways, this theta is equals to this theta. No doubt about it. And sorry. So okay. So we were discussing about the reflection of light, and then here we stop. So you can see here, what will be the light ray? The light ray which comes out will be 45 degrees, because this is 90. This will be 45. This will be 45. And yeah, uh, this also will be 45 and 45. So light ray which comes out will be of 45 degrees. So with whatever angle it is falling, with the same angle it just comes out. Okay, right. Now there's another problem which shows like this. A person is standing 3 meters from the mirror, and he is moving 2 meters away, 2 meters away from the mirror, right? Then he is asking the distance between the person and the image. Person and image. Okay, initially he was at 3 meters and he just moved back. It will be 5. Okay, then where will be the image formed? Image will be formed 5 meters backside of the mirror, isn't it, right? If this is the mirror and the person is standing somewhere, initially he was 3 meters, now he has moved to, and the image initially was 3 meters only. If he is 3 meters, image also is 3 meters. Now he is moving away 2 meters. Then the image also moves away 2 meters. Then what is the distance between the person and the image? Here it is 5 and here it is 5. The total D will be 10 meters. Okay. So this is how we find out the number of images and then find out the mirror images of the thing, right? Okay, so this is about the reflection of light on plane surfaces. So we will just end up this, and in the next class we will see with the new, I'll come out with the new topic, maybe the continuation of this on the curved surfaces, right? Until then, take care, stay safe.